Hello, math students of mine. Today, I'm asking you to watch 2 videos on inequalities. This is the first video I've asked you to watch. We're calling it Inequalities Part 1, and it's just an introduction. Everybody, this is going to be major review for mostly everyone, I would think, from your previous math course. But I think it's important to go over some key concepts before we really dive into this. So let's take a look here at our symbols. First bullet, this is less than or equal to, and I wrote that over here, less than or equal to. This is how you read it. The second bullet is just less than. The third bullet, greater than or equal to. Fourth bullet is just greater than. And the fifth bullet, this equal to with a slash through it, is read not equal to. So just some food for thought over here on the side to use some of these symbols. Like, for example, if I want to use the first one, less than or equal to, I could write a statement like this. 5 is less than or equal to 7. That's a true statement. 5 is less than or equal to 7. I could also write 5 is less than or equal to 5. Because even though 5 is not less than 5, it's equal to. So that's how that symbol works. The second symbol, less than. Well, I could do the first statement, 5 is less than 7. That's true. But I can't do 5 is less than 5. This would be no good. I couldn't do that because that is not true. For this, you would need the equal to. So this one, no way. Okay, third bullet, greater than or equal to. Okay, greater than or equal to. Well, I could do like 6 is greater than or equal to 1. That's a true statement. 6 is greater than or equal to 1. I could also do 6 is greater than or equal to 6. That's true. 6 is equal to 6, so it follows that that's okay. Okay, let's try another one. Greater than, just greater than. Well, this one would hold true. 6 is greater than 1, but I couldn't do this. 6 greater than 6? No way. 6 is not greater than 6. It's equal to. So that's a no-go. And last but not least, not equal to. An example of that might be something like this. 3 is not equal to 8. That's true. 3 is not equal to 8. 3 equals 3. That's the only time I could put the equal sign. Any other number that's not 3, I would have to say not equal to. Okay, let's go down to the next part here, this property I've written for you. It says for all real numbers, that's all numbers, A and B, exactly one of the following is true. And these are the only 3 cases you can have. Either A has to equal B, kind of like 3 equals 3. A has to be less than B, or A has to be greater than B. If you have 2 numbers and you're comparing their values, they're either equal, one is less than the other, or one is greater than the other. Pretty simple stuff. Okay, let's move on. What does a math expression with an inequality symbol mean? So now we're going to get into some of the items you were going over probably last year. Let's look at the first one. It says x is greater than or equal to 3. Let me blow that up. X is greater than or equal to 3. Okay, so we know that x is just holding the place for a number or a set of numbers. Okay, so all numbers, any numbers, bigger than or equal to 3. So how do we represent those solutions? I mean, I could start guessing and checking. I could say, all right, Miss Callahan, I've got a solution. 10. 10 is greater than or equal to 3. So 10's in the answer key. I could say, all right, well, 12. 12 is greater than or equal to 3. Check. 3.1 is greater than or equal to 3. Check. There's a ton of numbers that are greater than or equal to 3. So how do we represent all those numbers? Well, it's pretty cool in the number line. So what you do is if you look at where 10 is, well, 10's up here. This is 10. And if you look at 12, well, that's up here. So 10, 11, 12, that's right there. And 3.1, well, that's right here, 3.1. All these numbers are solutions, but so are a bunch of other ones that I didn't even mention. So everything higher than 3 is going to work, all numbers that are bigger than 3. So let me color that part of the number line. I'm going to kind of shade over that dark. Everything bigger than 3. These are all good answers for this number. But we can also include 3. Remember from up above? 3 is also greater than or equal to 3 because they're equal. So we can actually go to the 3 and put a dot there, and we can close it in to show, hey, 3's included, but so's everything bigger. So this is the graph of this inequality. Pretty cool. All right, let's look at the next one. All numbers, x, all numbers, less than -1. Well, there's a ton of numbers less than -1, like -2, like -3, like -4, like -5, like -1.5, -2.5, -3.5, and so on. There's tons of them. They're all this way, less than -1, but not -1. -1 is not less than -1. They're equal, but this doesn't have an equal. So we represent that mathematically by going to -1 and saying, no way, not you, but everything less than you is good. Everything less than, but not, nope, not you. So we open circle this. Okay, and here, our last one in this section, we have x does not equal 6. Well, okay. All numbers not equal to 6 are the solution to this. Any number but 6. So how do we represent that? Well, here's 6. We're not allowed to have 6, so let's open that. Nope, not 6, but anything else is good. The shaded part on this number line are all numbers not 6. Check it out. Okay, pretty simple. Okay, let's look at example 1. It says, and this is true, to vote in the United States, a citizen must be, here it is, 18 years of age or older. So you can be 18. 18 or older, but nothing less. Okay, write an inequality that describes the age and years of voters in the United States. Okay, so let's let A equal the age of U.S. voters. And now let's write an inequality statement. You might want to pause the video and try it yourself and come back to see if you're correct. Well, if you have to be 18 years of age or older, then I'm going to say your age must be greater than or equal to 18. 19, 20, 21, 22. And you can be 18. That's why I put the equal to on there. Greater than or equal to 18. Graph it. Okay, I didn't provide a number line here, so you would just whoop, draw your number line. I'm going to put 0 way down here. And I'm just going to go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. See, I want to get that 18 on there. So all ages bigger than 18 or equal to. Let's close that dot on the 18. Hey, 18-year-olds can vote, but so can everybody older than them. Glorious. That's your answer. Isn't this easy? It's such a review for you, I know. Okay, flip it. Let's finish this up. On the back, example 2. Look at this. You've seen that before. You see them every day. Speed limit sign. Speed limit's 25 miles per hour. Letter A. The sign above is something we see every day. Write an inequality that describes the speeds in miles per hour a vehicle could be legally traveling near this sign. All right, so you know if you're in the car, You can go up to and including 25 miles per hour, but nothing more. This is the limit, no more than 25. So let's let S equal our speed in miles per hour. And our speeds must not exceed 25. So they must be under 25, less than or equal to 25. You can be going 25, but you better not be going 26. Although, wink, wink, I know we sometimes do. But this is what a speed limit means. Okay, B, would it be appropriate to graph this inequality on a number line by drawing an open or solid dot with your arrow? All right, because you can be going 25, I'm going to say solid, because you want to include that 25. You're allowed to go 25 and not be speeding. Cool. All right, last example, and you probably remember this little nugget from last year. An interesting fact about inequalities is that, you ready? When you divide both sides of an inequality by a negative number, the inequality sign flips 180 degrees. Okay? But I'm asking you, why is that true? Like, did somebody just tell you that? Or why is that true? It's like a weird little fact. So I gave you a little example here, so check it out. It says 4 is less than 6. I'm going to blow this. It's just the writing is so small here. So 4 is less than 6. True? Yeah, 4 is less than 6. As far as I know, 4 is less than 6. Next, divide both sides of this inequality by -1. So you can see what I did here. See how I took 4 is less than 6 and I divided both sides by -1, which is legal because I did it to both sides. So now what I get, well, 4 divided by -1 is -4, and 6 divided by -1 is -6. And if I just bring this inequality symbol right down like we always do, I've got a statement here that says -4 is less than -6. No, it's not. Look at a number line. Here's 0. Here's -4. Look where -6 is. Is -4 less than -6? I don't think so. This is less than. Look at the direction. So you take this little symbol and you flip it 180, and now your statement is true. -4 is greater than -6. So the idea is, guys, you got to memorize this. When you're dividing by a negative number, only when you're dividing by a negative, in an inequality, you flip the symbol. Awesome. Your first video is done. Now you're going to take your next sheet, your purple sheet, and you're going to take notes on the second video. Hang in there.